Hey, Math 20-1. Today we're going to look at absolute value functions, start of this unit. So some initial introduction stuff. The absolute value of any number is its distance from the origin on a number line. So the absolute value of 6 is 6. The absolute value of -6 is also 6 because they are both 6 units away from 0 on a number line. So what's the value of each expression when x is 1? So we plug 1 in, and these absolute value signs act as brackets. We've dealt with this a little bit, so let's recall. Plug 1 in for x. 1 minus 2 is -1. The absolute value of -1 is 1. Same thing for part 2. Plug 1 in for x. 3 times 1 is 3, plus 4 gives us 7. The absolute value of 7 is indeed 7. And plug 1 in for x in part 3. -5 times 1 is -5. -5 minus 4 is a -9. Then we take the absolute value. Absolute value of -9 is indeed 9. All right. Complete the table below to graph the function y equals x and y equals absolute value x. So you guys have the table, you go complete it. When you're done, here's what it should look like. Notice that when x is -3, the absolute value of that number should be positive. When x is -2, the absolute value of x is positive 2, and so on. So if we look at these values in the table and graph the lines y equals x and y equals absolute value x, here's what we get. So the line y equals x and y equals the absolute value of x. So when x was -3, y was -3. Plot that point. -2 and -2, -1, -1, 0, 0, 1, 1, 2, 2, 3, 3. There's our line. Y equals x. Now when x was 0, y is still 0. 1 and 1 are still true. 2 and 2 are still true. 3 and 3 are still true. But when x is -1, y is no longer -1. Y is now +1. When x is -2, the absolute value of -2 is +2. So we get a curve that looks like a V. So it's no longer a single line. That's the positive values, and then we take the negative ones and take the absolute value of the negative x's. They become positive x's. So that's the graph of y equals absolute value x. All right. Sketch the graph of y equals the absolute value of 3x plus 6. Identify the intercepts, the domain, and the range of the function. So step 1, graph the line y equals 3x plus 6. If you recall, mx plus b form of an equation, the slope is 3 and the y-intercept is 6. We plot the y-intercept, the point at 6, and we rise 3, run 1. Rise 3, run 1 to the right. All right. So there's our line. Y-intercept's at 6. We rise 3, run 1 to the right. You could fall 3 and run 1 to the left. Since absolute value can never be less than 0, redraw the graph so that whatever is below the x-axis now appears above the x-axis. So from this x-intercept to the right, everything's above the x-axis, and that's all going to be fine. But everything below the x-axis has to become a positive value. When we talk about absolute value, negatives don't happen, so those negatives become positive. So we're going to get the V shape coming up like that. So if I graph it down in our second coordinate plane, that part of the graph down here gets switched to above the x-axis, and everything above the x-axis stays there. All right. Identify the x-intercept. Well, it still is -2, just like it was on the original graph of the line y equals 3x plus 6. So the x-intercept's -2. The y-intercept is +6, just like it stayed. The domain, x can still be any real number. The range used to be any real number for the line, but for the absolute value, now the range is y must be greater than or equal to 0. There is no negative when we take absolute value. All right. Note that the x-intercepts do not change. From the line to the absolute value, the x-intercept is the same. All right. It's at -2. Sketch the graph of the absolute value of -2 times x plus 2 all squared, add 2, and identify the intercepts, the domain, and range of this function. So again, step 1, graph the quadratic like we've seen before. So we know we're going to reflect it down. It's going to open down. We know it's got a stretch by a factor of 2. We're now going to move it 2 to the left and 2 up. So the vertex is at -2 and 2. It's going to open down, and it's going to be a vertical stretch by a factor of 2. I'm a parabola opening down. So beautiful drawing, I know. So there's our vertex at -2 and 2. Vertical stretch down. There should be arrows in the end here. If you guys put those in, that'd be great. Since absolute value can never be less than 0, we're going to redraw the graph so that whatever is below the x-axis now appears above. So this part of the curve is above the x-axis. That's not going to change. But these two legs below the x-axis will now become above the x-axis as an absolute value function. So this will now get drawn above the x-axis. So here's what the graph looks like after we include the absolute value sign. All right. So our little curve stays above the x-axis. Beautiful. The legs that used to go down now come up above the x-axis. They used to go down, and they come up above. All right. X-intercepts. Well, the x-intercepts over here are going to stay the same as the x-intercepts in our absolute value function. So the x-intercepts of this graph are -3 and -1. The y-intercept is 6. It used to be -6 if I'd drawn this one properly over here. Domain is any real number. Again, x can go any way we want, positive or negative, and range now is greater than or equal to 0. All right. Note the x-intercepts still do not change. They lie on the x-axis, so they're never going to be below. They're never going to change. They were -3 and -1. They're still -3 and -1. Let's talk about piecewise notation. Very important thing. The absolute value of x, where x is a real number, is given in piecewise notation. It looks like this. The absolute value of x equals -x when x is less than 0 and positive x when x is greater than or equal to 0. What does that mean? Recall the graph of y equals absolute value x. There were two pieces to the graph. When x was greater than or equal to 0, the line was y equals x. When x was less than 0, the line was y equals -x. All right, so those two pieces of the graph, they can't be drawn as a single line. All right, so the absolute value of x is not a single connected line, it's that V shape. So let's write each of the following functions in piecewise notation. Y equals absolute value of -2x plus 4. Well, it's pretty simple. Find the x-intercept of the function. You can do this by graphing, or you can do it by setting the equation where y equals 0. So the x-intercept of this function is 2. If y is 0, you substitute 0 in and you solve. Note that the x-intercepts are invariant points, and they're critical in writing the piecewise notation. So piece 1 is going to occur when the line y equals -2x plus 4 is occurring, and that happens when x is less than or equal to 2. Piece 2 occurs when x is greater than 2. So the equation for this line would be the negative of -2x plus 4, or positive 2x minus 4 if I substitute that, if I multiply that negative sign through. So what does this piecewise notation for this function look like? We would say this. Y would equal -2x plus 4 when x is less than or equal to positive 2, and y would equal 2x minus 4 when x is greater than 2. Let's look at the graph of that and see what it says. So graphing the function can help you understand the piecewise notation. So if we graph the function y equals -2x plus 4 like we did earlier, step 1 was to graph the line, -2x plus 4. And since the absolute value can never be less than 0, we're going to redraw the graph so what's below the x-axis now appears above the x-axis. So the original line, -2x plus 4, is in blue, and that would have kept going after the x-intercept of 2. It would have kept going down this direction. All right, but the absolute value would have had that leg of the graph come up above the x-axis from 2 on. So the red part of the graph is the second part, or the second piece of this function. So the graph of absolute value -2x plus 4 is both parts of this, but those can't be expressed as a single equation for a line. So there are two pieces to this function that we have to equate. So the x-intercept is 2. This blue part of the graph is the line y equals -2x plus 4, and that occurs when x is less than or equal to positive 2. So the blue part was the original line, negative 2x plus 4. That occurs when x is less than or equal to 2. The second part of the line, the red part, is y equals 2x minus 4, and that occurs when x is greater than 2. So the x-intercept is the invariant point, and it plays that important role for identifying what values of the variable x occur for each piece of the function. So piecewise notation again. Negative 2x plus 4 occurs when x is less than or equal to 2, the blue part of the graph, and the function is 2x minus 4 when x is greater than 2. That's the red part of the graph. The absolute value function includes both parts. You can write it as two pieces drawn just like that. So write y equals absolute value of x squared minus 4x plus 3 in piecewise notation. Step 1, find the x-intercepts of the function by graphing, or set the function equal to 0. Solve for it. So you guys should be able to do that. If you do that, you find out that the x-intercepts are 1 and 3. And again, these are going to be invariant points. They're very critical in writing piecewise notation. Invariant means they're never going to change. All right. So piece 1 occurs when we have x squared minus 4x plus 3, when everything inside the absolute value sign is positive. And that's going to occur between the two x-intercepts when x is, outside the two x-intercepts when x is less than 1 but greater than 3. The second piece of this occurs when x is greater than 1 but less than 3, so in between the two x-intercepts. And that's going to be the negative part of this function. So the negative of x squared minus 4x plus 3. Or if you multiply through by that negative sign, you get negative x squared plus 4x minus 3. So the piecewise notation for this function would look like this. X squared minus 4x plus 3 when x is less than or equal to 1 but greater than or equal to 3. It would be the negative of that, so negative x squared plus 4x minus 3 when x is between 1 and 3. Right. Again, if you want to see it on the graph, helps us understand piecewise notation. So let's graph this function. Like we did earlier, if we graph the quadratic, x squared minus 4x plus 3, and then change everything that was below the x-axis, make it above the x-axis, here's what the absolute value function would look like. X-intercepts are 1 and 3. There's the first part of the graph. There's this, it's going up. Second part of the graph, it's still going up. The curve of the quadratic would have went below the graph, but now, because it's the absolute value, that curve's got to come up above the graph right here. All right. So we've got two pieces, the pieces in blue that don't get affected by the absolute value, and the piece in red, which would have just continued going on below if it was just a quadratic, but we take the absolute value of that, it becomes above the x-axis. So there are now two pieces of the graph. The parts in blue were the equation x squared minus 4x plus 3. They're still part of the original quadratic function, the original parabola. The other piece of the graph is the red part, negative x squared plus 4x minus 3, that had to get moved above the x-axis to satisfy the absolute value function. All right, so 1 and 3 play important roles. When x is less than or equal to 1 or greater than or equal to 3, we've got our original parabola, x squared minus 4x plus 3. When x is when x is between 1 and 3, we get this function, negative x squared plus 4x minus 3, which is the negative of everything inside the absolute value sign in the original function. So piecewise notation for this function. Like we said, you write those two equations and make sure you identify the restrictions on the variables. All right. There it is. So x squared minus 4x plus 3 when x is between 1 and 3, less than 1 but greater than 3, and negative x squared plus 4x minus 3 when x is greater than 1 but less than 3. Right. So 1 and 3 are the key roles. When x is less than or equal to 1 or greater than or equal to 3, we get the original part of that function. To satisfy the absolute value part, we do the negative x squared plus 4x minus 3. Means the bump goes up above